Hi, Year 9. So today's lesson is on Pythagoras' theorem, which is the theorem that we discovered at the end of the investigation from last week. I'm going to go through it again with you and show you a few examples and when you use it, and then you're going to do some yourself. So Pythagoras' theorem, it's a famous theorem, and it's to do with right-angled triangles. So if you remember, when we did our tilted squares, this white triangle here represented the tilt of the big square over here, okay? But let's just think about this right-angled triangle here that we've got. So what I'm going to do, I'm going to label up the sides, and we label it up in a particular way. So the short sides are around the right angle, right? These are the sides that touch the right angle. These are the shorter ones, and we're going to call them A and B. Okay, and then the long side, which is always opposite the right angle, okay, it doesn't touch the right angle, we're going to call it C. Okay, and the other word for the longest side, you might know, in a right-angled triangle, the length C is called the hypotenuse. Okay, so it's just got a fancy word for it. Okay, so that's always going to be the longest side, the hypotenuse. Okay, and then what we did was we put squares on each of these sides. So A has a square, B has a square, C has a square. Then these areas of the squares are linked to each other. All right, so the A square, if I square it, I get A squared. That'll be the area of this square here. B squared is the area of this square here, and C squared is the area of this square here. And what we discovered was that the two small squares add up to the big square. So if I write down Pythagoras' theorem, that says this. So A squared plus B squared equals C squared. Okay, and that's Pythagoras' theorem. All right, so what that means is that if you know two of these sides on this right-angled triangle, you can work out the third one by using this theorem that's over here. Okay, so I'll show you some examples, but first of all, it's important you write this down and maybe draw this diagram so you can see how to use it. Okay, so let's look at a couple of examples and I'll show you how it works. Both of these white triangles are right-angled, so let's put the right angles in. Then I'm going to put some numbers on these sides, okay? So let's say that this side length is 3, this side length is 4, and I want to work out what the hypotenuse is this time. Okay, that's the long side. So to do it, I can, well, if you don't have the squares on first of all, you can draw them on. Okay, I've drawn on the squares for you, which you might want to use. Once you've drawn the squares on, you can fill in the areas. So 3 by 3 makes, I'll change colour. 3 by 3 makes 9, 4 times 4 makes 16, and this thing, we don't know what this is, we can call it maybe C squared, okay, because C is what we use to label this missing side, isn't it? So using Pythagoras' theorem, we can say A squared plus B squared is C squared. Okay, remember this one over here has to be the long side, right? The two small ones have to add up to the long square, the big square, so that has to be the long side. We've got our numbers filled in already. Okay, then what you can do is, what you know is these two squares add up to the big square, so that means that this C squared must be 9 plus 16, which you can do, and that's 25. Okay. But then this is the area of the square that I want, but what I really want is the length of the side down here, okay, the length of the hypotenuse. So to go from the area of the square to the side length, you need to square root, okay? So if I square root, that will tell me what C is, and the square root of 25, the thing that squares, is 5. Okay, so the answer is 5. Okay, so I've written out my Pythagoras' theorem. I've put my numbers in. 3 squared makes 9, 4 squared makes 16, and then I've sorted out what it needs to be that length there, 5. Okay, let's do one more example. So now I'm going to put, now I'm going to show you what to do if one of the shorter sides is missing. Okay, so I'm going to do this. I'm going to say, right, 13 is that length there, and then this is going to be 12, and this one is missing. Okay, so we're going to figure that one out. So let's first of all write down Pythagoras' theorem. Okay, and again, remember this one over here on its own needs to be the long side. So this one is going to be the 13 because that's the longest. It's opposite the right angle. Now I can put some numbers in, but one of these two shorter ones needs to be missing, right? So I'm going to leave A as A because I don't know what it is yet. But then B can be this 12 here. Let's put down how we're leveling up. So A, B, or maybe put it underneath. That's better. And C. A squared we don't know. B squared is 12 squared. C squared is 13 squared. Okay, then I can fill in the numbers that I know. I can do 12 squared and 13 squared. And that's going to be the areas of the squares. 12 squared is 144. 13 squared is 169. So I can put those on like this, 144. This one don't know yet, but then 13 squared is 169. Okay, then the two small squares add up to the big square. And if this is one of the smaller ones, that means I can do a take away to work out this smaller square. So 169 minus my 144 will leave this one, and this one is 25. So this A squared here is 25. Okay, that's that number there. And to work out the side length, again, just like the last one, you can square root. Okay, so same there as well. So if you want to draw these squares on, it might help you out because you can work out the link between the three square sizes. Then if you need to go back to a side length, remember you need to square root that. Okay, because the opposite of squaring is square rooting. Okay, so what I want you to do today is, if I show you the work to do. Okay, let's just find it. Here you go. Okay, so this is the first little starter task to do. So I want you to fill in the missing areas first of all. Okay, so just the square sizes just to start you off. Then after that, there's a page on this booklet I want you to do, and it's going to be let me get to it. This page here. Okay, so this page here, I'll tell you which one it is. Page 39. I want to work out anything that's kind of missing on the grid. So if I start you off with the first one. So for this one here, so use the theorem to write an equation that shows how the sides are related to each other. So all that means is you take the small sides, you square and add them, and that will be the big one squared. So 8 squared, that the square on that side, plus the square on this side, equals the square on the hypotenuse, which is c squared. So that's all you've got to do for these first ones. Then for 2, you complete the table, you square the numbers on the top, so 3 squared, 9, 4 squared, 16, 5 squared, 25, and carry on. Then using the table, you can then go backwards. So the square root of 25, if you unsquare it back to what it started with, that'll be 5, okay? So then square root of 100, what squared on here to make 100, and so on. Then for 4, you want to find the lengths of the hypotenuse. The first one I've already done for you because that was one of our examples. So this square is 9. This square is 16. So this square is the sum of these two. 9 plus 16 is 25. So square root that, and h is 5. Okay, so 5 is the answer to the first one. Can you do the same with these ones? Then using the table of square roots here, these nasty square roots, you can use these 1 decimal place numbers here. So find the missing values using the theorem. Okay, and that's today's work. Best of luck with it, and if you've got any problems, I will be in college today, but I can hopefully get to your emails at some point during the day. All right, thanks very much, Year 9.